In the heat of the summer, some clouds in the sky can be a welcome break from intense heat. Big, puffy clouds drifting overhead might bring a moment of shade and a cool breeze. On the other hand, a thick layer of overcast can make a warm day feel warmer and muggier. The average cloud cover experienced in different parts of the world affect different types of weather and climate conditions. When the sun's energy enters the atmosphere, some of it is reflected off of clouds. This means that high cloud cover can contribute to a cooling effect. More radiation reflected means less heat present in the atmosphere. But it's not just the presence or absence of clouds that affects temperature on the ground, it's also the duration and type of cloud cover. If it is overcast all day long, it will take longer for the ground to heat up because clouds are blocking incoming solar radiation. On the other hand, consistent cloud cover in a given area can also keep the ground relatively warm. Even though clouds do reflect some radiation and contribute to overall climate cooling, clouds also trap some heat beneath them, insulating and warming the ground below. This thermal radiation, where heat is reflected off of Earth's surface and then reflected off of the underside of clouds, trapping it underneath, has a major impact on the perceived temperature on the ground. On a day with a layer of low, thick clouds, about 90% of the heat that bounces off of Earth's surface is returned when it is reflected off the bottom of the clouds. Some of the sun's radiation passes through the clouds and heats up the ground below. The ground radiates that heat back up to the sky. If there is a thick blanket of clouds, oftentimes some of that heat is absorbed by the cloud layer and keeps the ground insulated. The absorption is due to the greenhouse effect, the warming of the ground due to the trapping of solar heat in the atmosphere. There are specific atmospheric gases that contribute significantly to this effect, such as carbon dioxide and water vapor. Clouds are comprised of water vapor, which act as a very strong greenhouse gas. Greenhouse gases cause about 50% of heat to be retained, contributing to warming. Cloud cover is defined by the approximate fraction of the sky that is covered. These terms might sound familiar as meteorologists refer to them when they give weather reports. Skies are considered to be clear skies when clouds cover 0 to 1/10 of the sky. Some clouds might be present on what is considered a clear day, but very few. Scattered clouds occur when clouds cover 1/10 to 5/10 of the sky. This type of day includes some clouds and some bright sunshine. Broken clouds are defined as conditions in which clouds cover 5/10 to 9/10 of the sky. The sky is mostly cloudy, but occasional sunlight breaks through. Overcast skies are defined as a sky fully covered by clouds. This is your standard gloomy day, as some might say. It seems contradictory that cloud cover can both contribute to cooling and warming at the same time, but it really depends upon the type of cloud coverage, the duration of cloud cover, and the time of day. While the global average of cloud cover does not change much on a yearly basis, cloud cover varies significantly on a daily basis and from region to region. Some places experience seasonal cloud cover, others inconsistently from day to day. Let's take a winter day in a cold region, for example. Under the same atmospheric temperature, a clear day is likely to feel much colder than an overcast day due to the insulating effect of clouds. Let's also look at a hot summer day in a warm region. Under the same atmospheric temperature, a clear or scattered cloud day is likely to feel much warmer than a day with broken or overcast skies, since a thick cloud layer will block more of the intense solar heat from the surface. At night, more cloud cover leads to more insulation, since the sun has set and there is less reflection of heat off of the top of clouds. During the day, more of the radiation is reflected off the top of clouds, hence an overall cooling effect. Whether warm or cool, generally speaking, more cloud cover equates to milder temperatures than the day would be without clouds. Cloud coverage can have an impact on weather and climate by both reflecting and absorbing solar radiation. Heat is reflected off of the top of clouds, causing a cooling effect. Heat is absorbed by clouds due to the greenhouse effect, or reflected off the ground and then bounces back off the underside of the clouds, causing a warming effect. The more cloud coverage, the stronger the effect of warming or cooling. Cloud coverage can range in an increasing percentage of the sky from clear skies to scattered clouds to broken clouds to overcast skies. Whether the effect of clouds causes warming or cooling depends on the amount of cloud coverage, the duration of cloud coverage, and the time of day. Cloud coverage can greatly affect the temperature of a given area and the climate in general.